This video will show you the Navier-Stokes equation for Cartesian coordinates. And we have here is the Navier-Stokes equation for x direction. So from previous lesson, we know that Navier-Stokes equation for x direction can be written like this. Rho del u over del t plus u del u over del x plus v del u over del y plus w del u over dz equal to rho g at x direction minus del p over del x plus mu dynamic viscosity times del square u over del x square plus del square u over del y square plus del square u del z square. So this is the long version of Navier-Stokes equation. But in some other textbook, they will give you Navier-Stokes equation like this. So it's still showing you the correct Navier-Stokes equation because in second row here, what we do is we bring the value of density here to the right hand side here. So we could cancel the value of density here and the term is become g at x direction, and we have the second terms here. We'll have 1 over rho here, and we will have mu over rho at these terms. And then we also could simplify, become this one. So the obvious one is the mu over rho here can be simplified into nu, the kinematic viscosity. Rho is the density and mu here is the dynamic viscosity, and mu over rho will give you the dynamic viscosity or nu. And for the last term here, I would like to introduce you the usage of capital du over capital dt and the meaning of nabla here. The du over dt can be referred as this one. For example, if we have d over dt, but the d here must be written in capital D, we have capital D over capital dt here, and it is equal, this term is equal to del over dt plus u del over dx plus v del over dy plus w del over dz. So for example, we have du dt here, we have an element u here, the velocity at x direction. So what we need to do is we just add the u at this point, and so on. So the du over dt here means it is equal to del u over del t plus u del x plus v del u del y plus w del u del z. So this is the simplification of this term. We could write as capital du over capital dt. And then the term of this one, it can be written as nabla. So the shape of triangle like this is called nabla, and this is the nabla square. So the meaning of nabla square is del square over dx square plus del square over del y square plus del square over del z square. So if we have u here, del nabla square u here, so means it is del square u over del x square plus del square u over del y square plus del square u over del z square. So this is the simplification from this term, and we simplified it into the symbol of nabla. In some textbook, they will use nabla without power of 2. So the meaning is still the same. If nabla square, so you have all terms in the right hand side here is by the power of 2. If the nabla only, so you could remove the square by the power of 2 here. So because the nabla is power of 1, so the terms here it must be in the power of 1. So this is the two terms that you need to understand, because in some textbook, or might be, it is easier for us to remember the Navier-Stokes equation by remembering this short term of Navier-Stokes equation. So this is for x direction. So we use the velocity of u here, and the gravity here is the gravity as at x direction. And this is the Navier-Stokes equation for y direction and for the z direction. So almost all the same, but the difference is for y direction we are using v as our component velocity here. So everything here, if you see, we are using v, and the gravity here is gy, mean the gravity at y direction. And this is the Navier-Stokes equation for z direction. So everything is remain the same except the velocity components. Now we are calculating the value of w here, the velocity component for z axis, and the gravity here must be written as gz because we are focusing on gravity that acts on z direction. So in our calculation, gz and gx is actually equal to 0 because gravity only acts on y direction, on vertical axis. So I hope you could remember the Navier-Stokes equation, or at least you need to remember the Navier-Stokes equation for x direction like this, and then the meaning of capital D over dt and the meaning of nabla.